Alright, so we finished up section 4.3, which is all about finding equations of lines that are parallel or perpendicular. What we're going to look at in 4.4 still involves lines, but we're going to look at what's called a scatter plot. And what we might do is draw a line on the scatter plot. So what is a scatter plot? So on your guided notes, right at the top, it says a blank, and you want to fill in what's in bold. So a scatter plot is a type of graph, like a bar graph or a line graph or something like that. This is a little different. So a scatter plot is when you want to show some type of connection or some type of relationship between two sets of data. So you might do a survey, and you might ask people, how long did you study for the test? And you give them choices like, between 10 and 20 minutes, 20 and 30, 30 and 40 minutes, something like that. And then after they take the test, you go back and ask each one of those people, what was your grade? So you could make a scatter plot of how much time they studied and the grade they got on the test. And the idea is, if you made a scatter plot and it looked like this, just kind of making a rough scatter plot, and this was how much time they spent studying on the test, and this was their grade. If the dots line up in a pretty straight line, then that suggests there's a connection between time spent studying and the grade you got. In this case, as the time goes further and further to the right, as you spend more time studying, the grade is going up higher. So that would mean there's a connection. Now, if you did the same thing and you asked people, how much time did you spend studying and what grade did you get, and the data looked kind of like this, then that would mean they're not really in a line, and there was really no connection. This person studied a lot, and they got a pretty low grade. This person studied a lot, but they got a higher grade. This person hardly studied at all, and they got a really high grade. So there's no pattern there because the dots aren't lining up in a line. So that's what we look for in a scatter plot. Do the dots line up, pretty straight going up, or they could also line up pretty straight going down. Either way, it means there's a connection. Right? And there's a name for a connection. I'll tell you what the name is in a little bit. So when we create a scatter plot, you're graphing a bunch of ordered pairs. Now, if you only had like 2 or 3 points, if you only asked 2 or 3 people, how much did you study and what grade did you get on the test, that's not enough people. The more people you ask, the more likely you are to see a pattern. So if you ask 100 people, that's a good amount of people. So in order for a scatter plot to actually have some type of meaning, you need to ask enough people when you're doing your survey. Another example of a scatter plot you could do is how much time you spend working and how much money you make. Do you think there'd be a connection if you get paid by the hour between how many hours, how many hours you work and how much money you make? What do you think? Lexi, what do you think? Yeah, there should be. If you get paid by the hour, then the more hours you work, the more money you should make. So if you made a scatter plot, you should see a pattern in the scatter plot. Now, somebody that gets paid like a salary, where they make the same amount of money every week, no matter how many hours they work, you wouldn't necessarily see a pattern. I could work on grades 5 hours outside of school this week. I could work on doing my grading 30 hours outside of school this week. It wouldn't make a difference what I get paid because I don't get paid by the hour. So there wouldn't be a connection between the time I spend grading and how much money I make. So here's an example of a scatter plot, and I think you guys have this one on your guided notes. And when you have a scatter plot, you need to make sure you label each axis. So on the x-axis here is how much sugar is in the smoothie, and on the y-axis is how many calories are in the smoothie. So we have 3 questions. All right, I think you guys have A, B, and C next to that scatter plot. Those 3, okay. So let's see if we can answer the 3 questions under example 1. It says, how many calories are in the smoothie that contains 56 grams of sugar? Okay, so how many calories are in the smoothie that contains 56 grams of sugar? So what you want to do is go over to where you think 56 is, and then go up on the graph till you find it, and then go left, and that tells you how many calories. Yeah?
270.
Yep, I'd say 270. So now let's try it the other way. It says, how many grams of sugar are in the smoothie that contains 320 calories? So now go to 320, go over, and then go down. And that'll tell you how many grams of sugar in that smoothie. Yep? Yep. It looks like if you go to 320, it's 70. Now, look at all the blue dots. Does it look like they line up in a line? It doesn't have to be a perfect line, but does it look like there's a pattern to the blue dots? Lexi? Yeah, there's generally a pattern. I mean, they don't look like this. I mean, if the dots look like that, that's just a pretty random picture. But these dots have more of a pattern to them. And that's what part C is asking. What tends to happen to the number of calories as the number of grams of sugar increases? So look at the graph. As you add more sugar to the smoothie, what does it look like is happening to the number of calories? Yeah?
They increase.
They increase, yes. The calories increase. So if your dots line up in a pretty straight line, then you can find a pattern like this. So any question why as the number of calories, any question why as the number of grams of sugar goes up, the number of calories goes up, based on this picture. Okay, so what that means is there is a connection here between how many grams of sugar and how many calories in the smoothie. There's a name for that. The name for that is called a correlation. Correlation means that there's some type of connection between two things. So on the blank, it says a blank is a relationship between data sets. You want to fill in correlation. And then on the second line, it says you can use a, and you want to fill in what I just underlined. You can use a scatter plot to describe the correlation between the data. And the reason a scatter plot is helpful is because it's a picture. Imagine I just gave you a table of data and said, look at all these numbers and tell me if there's a correlation. So let's say I asked you to look at this table of data and tell me if there's some type of correlation between the total defects, maybe this is like a machine, and column A. Why is it hard to figure out if there's a correlation just looking at all those numbers in a table? What about a scatter plot makes finding a correlation easier? Yeah?
You can see if there's no pattern.
Right, you can see if there's a pattern if the dots line up straight. So if I were to graph total defects on the x-axis and the A number in the y-axis, then I would get dots that show me a picture. If the dots look like this when I graph them, then I would say there's no connection between this first column and second column. If I graph all those points on a scatter plot, where like this is my x value and this is my y value, so think of each one of those as like a coordinate. If I graph them and they look something like this, then I would say, yeah, it looks like there's a pattern with those dots. Right? But without graphing it, it's really hard to look at a table and tell, because I can't visualize all these numbers in my head. I need to see them as a picture. And there's really 3 different types of correlations you can have. So on your guided notes, you have picture, and the first one goes up and to the right, and I think, did I already fill it in at the top? It says positive correlation. Okay, so this is a positive correlation. Positive correlation means that as you go to the right, it goes up. Think of it as like positive slope. It goes up. What do you think this one would be called? As you go to the right, it goes down. And they're in a pretty straight line, so there's definitely a correlation there. Yeah?
Negative.
Yeah, that's a negative correlation. So negative correlation means as you go to the right, it goes down. And then something like that. The points don't really show any pattern at all. Yep.
No correlation?
Yeah, there's no correlation here. So I don't know what the x-axis and y-axis represent, but whatever it is, there's no correlation. Trying to think of 2 things that probably don't have a correlation. Maybe, let's say, something like, you know, the year you bought your house and how old you are. I mean, why would there be any connection between those 2 things? The year that your parents bought their house and then your age. If you were to graph those things, I think it would be pretty random. You know, people could have bought a house a long time ago and you're very young. They could have bought a house a long time ago and you're older. There's really no reason there should be a connection between those 2 things. Okay, any questions on that? So let's look at a few graphs and see if there's a correlation. So example 2, tell whether the data shows a positive, negative, or no correlation. So the first one is a graph of how old somebody is and how many vehicles they own. Now, you might have a certain thing. You may think a certain way, oh, if you're older, you've probably owned more vehicles in your life. But whatever you think about it, it doesn't matter. You have to look at what the data is showing. So when you look at this data, does it look like these points are in a straight line? Michael? No, they're not really in a straight line. They're kind of all over the place. So we have somebody who's older here, who's owned only 3 cars. Then we have somebody who's really young in their 20s and they've already owned 4 cars. So there's really no connection there. So what would we call this? Positive correlation, negative, or no correlation? Yeah, no correlation. There's no line that I could draw that would really go through these points. They don't line up in a line. Let's try this one. So this is a graph of the temperature and the number of coats that a store sells. What do you think here? Does it look like these points have a correlation? And if they do, would you say it's positive or negative? Yeah?
Negative.
Yeah, this is a negative correlation. So what does that mean? If I asked you to describe to me, what does that mean? There's a negative correlation between the temperature outside and the number of coats that a store sells. Can someone describe to me what's really happening in this picture? Yep.
As the temperature increases, the amount of coats also increases. Well, when we the coats they have, when the temperature is decreasing, the amount of coats is increasing.
Okay, so yeah, when the temperature starts... That's okay, yeah. When the temperature starts to get colder, the number of coats they sell goes up. Or you could also say as the temperature gets warmer, the number of coats they sell goes down. So that's what it means to have a negative correlation here. As one thing is going up, the other thing is going down. As temperature goes up, coat sales go down. Let's look at this one. Stopping distance. So this tells you how long it's going to take you to stop your car based on how fast you're going. Does it look like there's a connection here? Or I should use the correct word, correlation. Does it look like there's a correlation? Yes, I would say those points are almost in a perfectly straight line. Not quite, but they're pretty close. And would you say that this is a positive correlation or a negative correlation? Yeah? This is positive, yeah. So can someone describe to me what do you think that means here? If there's a positive correlation between how fast you drive and how long it takes you to stop your car. Yeah.
The numbers keep rising at a constant rate, kind of like almost.
So can you describe it like Lexi did before as what happens? This happens.
So the more distance you go,
Start with the x-axis.
okay. So like the faster you go, the
Yep.
more distance it takes to stop.
Exactly. The faster you go, the more distance it takes to stop. As your speed goes up, your distance goes up. That's what a positive correlation means. They both increase. Speed increases, stopping distance increases. And what we want to be able to do sometimes is something like this. Find a line that goes through the points the best that I can. Well, maybe that's a little bit off, but basically kind of like that. I want to find the best line that I can that goes through those points.
I go to bed.
Yep. We're going to talk about how you find this line. And that's what the graphing calculator that we're going to do a little bit with is going to do for us. It's going to find that line. It's going to tell you the best slope and the best y-intercept that it can. And the reason why you might want to find that line is because if I said to you, all right, I want you to predict how long it's going to take to stop the car if you were going 110 miles an hour. So maybe on like a racetrack and a driver had to stop real quick. Well, 110 is off the graph. But if I draw this line, I can use that line to predict. It might not be perfect, but I can get a rough idea. If a driver was going 110 miles an hour, their stopping distance would probably be right about up there. And I can figure out what that would be using the calculator. So that's why sometimes we want to find a line. It helps us to make a prediction. And there's a way to find this line by hand. Like I just estimated it by eye and I drew it in. That's not a very good way to do it. There's a way to use math and figure out exactly where this line should be, but it's pretty complicated to do by hand. It's very complicated. I don't remember off the top of my head how to even do it. So we're going to look at the calculator. All right, so example 3. It says to make a scatter plot of the data and tell whether the data shows a positive, a negative, or no correlation. Okay, so you all have a grid on your guided notes. And it tells you which one to put on which axis. So this is a scatter plot that involves the value of a car and how old the car is. So we're going to make a scatter plot and see, is there a pattern to what happens to the value of a car as it gets older? Let's see. What does it tell me should be on the x-axis? Yep.
The year, how old the car is.
Yep. So we're going to put the age of the car. So this is the age, and this is in years. And what's the highest amount of years that I have to go up to? Yeah? 8. So let's look at our graph and see if we've got enough space. 0, 1, 2, 3, 4, 5, 6, 7, 8. It's perfect. Okay, so I can just go by ones on the x-axis. Emily, what's going to be on the y-axis? The value. And that's the value. And that's in thousands. Okay, what's the highest value that I need to go up to? Yeah? 24,000. Well, if I go by ones, like 1,000, 2,000, 3, 4, 5, 6, 7, that only gets me to 8,000. So I can't go by ones. What do you think I should go by on the y-axis? Yeah?
4.
Yeah, we could go by 4s. That'd be plenty. I think we might even be able to get away with 3s. We do have enough room to go by 3s. So 0, 3, 6, 9, 12, 15, 18, 21, just barely enough space to go to 24. All right, and now let's graph the points. And the way you do this on the test, because there will be one like this on the test, you're just going to have to click. You're going to have to click 8 times for all 8 points. All right, so 124 would be right there. That's the first point. 2, 21. There's the second point. Can somebody tell me where's the third point? Just give me the coordinates for it. Yeah? 3, 19. So I'm going to go 3. This is going to go a little bit above 18. All right. Where's the fourth point? Yeah?
4,18.
Okay, so 4, comma 18. All right, so right about there. What about the fifth point? Yep.
5,15.
So 5, comma 15. Okay. And the sixth point. Where's that one? Yeah. 6, comma 12. Okay, definitely looking like there's a pretty good pattern so far. We got 2 more. 7th point, yeah.
7,8.
7, 8. So let's just put it a little bit below 9. And the last point, yep. 8, comma 7. So just put it a little bit above 6. Okay, so there's our scatter plot. Yeah. What do you think? Does it look like there's a correlation here? We'll start with that. Either a yes or no. Lexi? Yes. It definitely looks like there's a correlation. And would you say it's a positive or a negative? Yeah, that's a negative. Because as the age goes up, value is going down. You might say, well, what if it's an antique car? Is that, well, that's not what the data says here. We're not looking at those kind of cars. As the age goes up, the value is going down for these types of cars. So you want to put negative correlation. Question on that? All right, so if I was going to draw a line in for this data, I would probably do it about like that. Try to get as many points above the line as you have below the line, and then you might land some right on it. But that's a pretty good line just by doing it by eye. Okay? But I don't want to do it by eye. I want to use the calculator and this data to get me the most perfect line possible, not an estimate by me. Right? I want to know what would be the best slope of this line that I could have and the best y-intercept. And that's what we're going to talk about next. So I don't think there's a spot on your notes for this. But you know what? Right below, I would say on your guided notes, right below the chart or to the left of it, I would write this sentence down. Okay. So just put that like, don't put it on steps 1 through 4. And I think what we'll do for today, I think I'm gonna save the calculator for now. Okay, we're gonna calculate the line just by hand for today, like a simple way to do it. Okay, I'm gonna save the calculator. We'll just do it this way. This line in black is called a line of fit. A line of fit is a line drawn on your scatter plot that's pretty close to most of the data points. In this case, I would say that's a pretty good line of fit. If I said to you on the test to draw a line of fit for those points and you did something like this, I'd say no. That line isn't anywhere near the points. That's not a good line of fit. Okay, but that black one is. So the last problem we're going to do is we're going to find a line of fit, but we're going to do it by hand the simple way. We'll save the calculator for another time. Okay, so do you guys have on your guided notes, does it say using a line of fit to model data, and then there's 4 steps under it? Okay. So under step 1, the first thing you have to do if you want to do a line of fit is you need a scatter plot. There's no way that you can draw a line if you don't have a picture of the points. You need a picture. So make a scatter plot. That's what we did on example 3. So that's your first step. Make a scatter plot. Step 2 is to decide whether the data can be modeled with a line. Maybe the points don't line up in a straight line. Well, if the points don't line up straight, then we can't use what's called a line of fit. Maybe your points look like this. So if I had you make a scatter plot, and the points look like that, make that bigger so you can see it, I would say you're not going to be able to draw a line of fit through those red points. There's no correlation at all. Let me put it back the way it was. There you go. So in our problem, if we had to decide whether those points are in a straight line, I would say yes. The points from the last problem, they do look like they're in a straight line. So then we would continue on to step 3. Now I said we're going to do it the simple way. We're not trying to calculate the best possible line. That's what the calculator can do for us. We're going to do the best we can by hand. So we're going to draw a line that looks like it's pretty close to the data. We want to try to make it so there's as many points above the line as there are below. So I'll give people a second to copy that. And then we'll go back and look at my line and see, are there about as many points above the line as there are below it? So step 3, it's pretty good if you use like a ruler or use your ID. But you kind of want to draw something that's pretty straight. Straighter you make your line, the easier it's going to be to do. All right, so let's look at mine. I'm going to say I've got 2 points that are definitely above it. I've got 1 point that's definitely below it. And I've got 1, 2, 3, 4, 5 points that are at least touching the line a little bit. That's pretty good. I've got 4 points that are touching, 2 above, 1 below. You're not going to get it much better than that. If you drew your line like this, I would say, your line's too low. Every single point is above the line. You need to move it up a little bit. Okay, so that's a pretty good line. And then step 4. Step 4 is where you're going to write the equation of the line. And this is where it ties into what we've been learning in chapter 4, writing the equation of a line. In order to write the equation, I'm just going to stop right there for a second. You need to pick 2 points that are on the line. Okay, I want to go back to my picture in a second and then just look at that. And then I'll show you the rest. So you need to pick 2 points that are on the line. Let's go back and look. Now, the points that you pick do not have to actually be red dots. They just have to be on the line. So like if you wanted to pick this, let's say this one, I'd say that's a good point to pick. And you could pick, I think that's a good one right there, that's on the line. But you could pick any 2 points you want. You can pick this one if you want. You just have to find 2 dots that are on the line. If I was doing this and I wanted to actually pick points, I would probably pick this one and this one. Not only are they on the line, they were actual data points from the problem. But you just have to find 2 points on the line. Try to make the points as easy to work with as you can. Don't pick a point like this. The one that it's pointing to with the green arrow, don't pick that one. That's a good point because it's on the line. But the problem is, how are you going to figure out the value of it? That's like 2.5, and then it looks like maybe 20. That's too hard to figure out. Find 2 points that are on the line that are easy. So either look for a red dot that's already on the line, or look for a spot where the line crosses right where the grid meets. Like, that's a good one. Because I can easily tell it's 7, 9. Okay, try to find an easy point. But remember, the points don't have to represent actual data pairs. They just have to be on the line. Okay, so the last example, we'll go through these steps. We're going to draw a scatter plot. We're going to see if it can be modeled with a line. And if it does, then we're going to draw the line. And we're going to try to find the equation. So a couple things you need to remember to do this. You're going to need to know the formula for slope. We did that earlier in chapter 4. So to do step 4, you're going to need the formula for slope. You're also going to need that equation, because that's what our answer is going to look like. Does everybody have step 4? All right, let's try it. Do you guys already have this grid printed on your guided notes that says DVD sales? Yeah. Okay. So it says table below shows the DVD sales. Write an equation that models the DVD sales. All right, so we can't write the equation until we get to step 4. That's the last step. We got to do steps 1, 2, and 3 first. make a scatter plot, see if we can draw a line, and then actually draw the line. Okay, so it looks like they've already labeled everything. So let's just put the dots on the scatter plot. So 1, 19. 2, you're at 15. Okay, 3, we're at 13. Okay, if you notice a mistake, just let me know. 4, it looks like 11. 5, we're at 10. 6, we're at 8. So you can see what's happening. As time goes on, less people are buying the movie. Maybe because it's been out longer, people aren't interested in it anymore. But as the weeks go on, it seems like the money they make from selling movies is going down. 6, 7, I think would be about right there. And then 8, we're at 5. 8, 5. Okay, does it look like those points are in a pretty straight line? What do you think? Yeah, doesn't it?
Yeah, kind of.
Yeah, they're pretty straight. So I would say decide whether the data can be modeled with a line. Yes, it can. Draw the line. Okay, so now this is the part where, we're just going to kind of do it the best we can. And the nice thing about the smartboard is if I don't like where the line is, I can easily fix it. I'm going to say it goes through most of those points, but then I'm just going to bring it up a little bit because of that last point. This last point almost seems kind of weird. It doesn't really fit with the other ones, but I would say that's a pretty good line. We have 2 points that are below, 1 point that's pretty far above, and 1, 2, 3, 4, roughly 5 points that are touching the line. Okay, now I need to find 2 points that are right on that line. I think this is a pretty good one, right about there. What's the coordinates of this first green dot? Yep. 0, 18. And does anybody remember when you have a coordinate, the number with the 0 has a special name? Because it tells you where the line does something with one of the axes. Anybody remember what this number is called? Yeah?
Y-intercept.
Yes, this is your y-intercept. You generally want to try to find the one with a 0. That's going to make it a lot easier. So we've got that one. And does anybody see another good place that I could mark a green dot on the line where the grids meet? Pretty exact. Yeah? 5, 10. Yeah, I think you could use that one. If somebody said 9, 4, I would say you could use that one. The point is just find 2 points that are pretty close to the line. Okay? I'm going to use the 9, 4 because that one looks even closer to where the grid crosses. So I got 0, 18 and 9, 4. Okay, let's find our slope. y2 minus y1 over x2 minus x1. What is y2 in this case? Yeah?
4.
Yep, I would say this is my first point, this is my second point. So y2 is 4. What's y1? Yep.
18.
18. What's my second x value? Yeah?
9.
Yep. I'd say 9. And what was my first x value? Yep. 0. Okay. Let's find our slope. Well, 9 minus 0 is just 9. And what's 4 minus 18?
Negative 14.
Negative 14. Not a nice number, but we're just going to leave it like that. That's my slope. What's my y-intercept here? Where does this graph cross the y-axis? Yeah, 18. There's your M. There's your B. Can someone remind me what's the equation that we use when we're writing? We're not going to do the point slope. That's more complicated. That's for the parallel perpendicular. Let's stick with y equals mx plus b. Okay, so y equals, Natalie, what's my m value? Yeah, it's not really a nice number, but that's okay. Negative 14 over 9. And what's my b value? Yeah, 18. So that's the equation of the line that represents that data. And sometimes the slope doesn't come out nice. If it doesn't come out nice, just leave it the way it comes out. And notice, this wasn't really all mathematical. We kind of drawed the line by hand. So you might get a slightly different answer than someone else. And that's okay. Okay, so remember, first week of third quarter is this week. Tomorrow we will have a review day, and it will cover parallel, perpendicular, and the stuff we did today. Worksheet is online. It should be okay, but if you notice an issue, just let me know. So thank you to those people that let me know yesterday. 4.4 is the worksheet for tonight.